Welcome to Mr. Chalk's Revision Tips.
When answering exam questions, there are a few key things to remember, right? So just remember, exam technique is a key part in preparation for any exams, and it's something that you'll pick up the more you go and you do past papers. Right, so many questions in exams are repeats of what will be in old exams. So going and looking at lots of generic questions beforehand is a good idea. When going and answering and questions and reading them, there's a few things just take into account. Make sure you go read the question at least twice so you don't make any mistakes when you're reading them. As you're reading them, go highlight key information. Don't make assumptions about what the question is asking. Make sure after you've answered it, you go check your work for daft errors that you might make. And if it involves going and answering something where there's some calculation, make sure that you write your workings out down. Right, let's go and have a look at the question.
Questions about compromise conditions will often talk about the Haber process because that is a key example where lots of compromise conditions are used. So it's worth remembering that the Haber process is a process that we use to fix nitrogen to hydrogen to make ammonia. If we just quickly go and look at the process, so we obtain hydrogen and nitrogen gases. So nitrogen comes from there, hydrogen comes from, usually we get it from natural gas, and they're pumped into a compressor, so we increase the pressure. So the gases are pressurized to 200 atmospheres. These pressurized gases are then pumped into a tank at about 450 degrees, including an iron catalyst. Any unreacted gases, so any unreacted hydrogen and nitrogen, are fed back into the heater so they can be reused. So that means that we improve efficiency because we're not wasting any of the gases. So like we said, all these compromise conditions are there to go and help us increase the yield of the ammonia that we're producing. So ammonia is produced at high pressures, but the higher the pressure gets, the more expensive it gets to produce. Right, the temperature chosen is also a compromise. So a high temperature gives a fast rate of reaction, but actually decreases the yield of ammonia. So we can see here that we've got the pressure increasing. So as the pressure increases, the yield of ammonia increases. But you can also see, so that's the pressure, you can also see here that we've got different temperatures that it's being done at. So you can see that the best temperature for it to be done at would be 350 degrees. However, that would cause a much higher yield. However, it would slow down the rate of reaction. So a compromise of 450 degrees at 200 atmospheres, so just there, is used. So we just look at a question. So figure 2 shows information about the percentage yield of ammonia under various conditions. So the conditions used are 200 atmospheres of pressure. We do it at 450 degrees and we use an iron catalyst. So we're suggesting reasons why these conditions are used for this industrial process. There are a number of key things. So first we need to go and consider how they affect the rate of reaction. So you need to talk about the fact that the rate of reaction will be slow at low temperatures. So high temperatures will obtain a faster rate of reaction. So a compromise between a good yield and a reasonable rate is used effectively because we're going to go and use it about there. And you can talk about the catalyst also speeds up that rate of reaction. If we go and think about things that are going to affect the yield, you can talk about the fact that the best yield is obtained at a high pressure and a low temperature because this favours the forward reaction, which is exothermic. So the formation of ammonia is favoured at low temperatures. The formation of ammonia is also favoured at high pressures, because if you go and think back to the reaction, we've got 4 reactant molecules but only 2 product molecules. So if we're going to increase in the pressure on the side of the reactants, that's going to force it in the direction of the products.
So hopefully you have found that useful. If you've got any questions, then drop it in the comments below, and we'll be uploading a lot more. Right, good luck, folks.